Okay, somebody asked about question number 5 from the homework, where you're given the polynomial as with some constant k built in there. And so they say, for example, if you take the function that's shown here, the x squared plus, or x cubed plus kx squared minus 5x plus 6, you divide it by something, in this case x plus 2, they tell you, okay, the remainder is going to be 16. What is the value for k? So we can do that fairly, I think, in a straightforward way if we just kind of break the problem down like we did in class. In other words, if we understand that dividing by x plus 2, we're actually dividing by, and this makes it easier to think of it this way, x minus negative 2. In other words, it's the negative 2 that we're gonna use to find our remainder. And the remainder theorem says that if we divide by x minus negative 2, then f of negative 2, that's where that 2 comes in there, okay, is going to give us our remainder. Except for this time, we know what the remainder is. We know the remainder is going to be 16. So then all we have to do is figure what f of negative 2 would be in this function up here. Okay, so I'm going to write out f of negative 2 in terms of that function there. So it's going to be negative 2, don't forget to put it in brackets, cubed, plus k times x squared, but it's going to be negative 2 squared. So always substituting in for x as negative 2, minus 5 times negative 2 plus 6, and that's all going to equal 16. Okay, so we have some pretty heavy-duty simplifying to do here. This is going to be negative 8 plus 4k plus 10 plus 6 equals 16. Okay, well, if we, let's see here, we get negative 8 plus 10 is, pardon me, is positive 2, plus 6 is positive 8. That gives me 4k plus 8 equals 16. And if you subtract 8 from both sides, you get 4k equals 8. In other words, k equals 2. Okay, so that's kind of the basic premise of what you do there. Just substitute everything that you know, knowing that f of negative 2 is going to be 16. That's what the remainder theorem says, and kind of work backwards that way. So hopefully that'll help you out with number 5, and also number 7 as well, or whatever it was that I assigned. All right, there you go.